Welcome back to the LRC. I can't think of a hook, so let's get started. Today's lesson is all going to be about basic formulas, which are essentially just the formulas to find the terms that we discussed yesterday. The most basic formula that we're going to be tackling is the speed is equal to distance over time formula. To briefly explain the logic, the reason this is because speed can be defined as how much distance can you cover within any given unit of time, let's say seconds. To illustrate this, let's say Tommy can run 250 miles in, let's say, 25 seconds. Speed just aims to see how much miles can you cover per second, which is why you have to divide the distance by the time and you'll get 10 meters per second. Now, the triangle you see here on screen, the one over here, is just basic algebraic manipulation to show how you can get all of the other things. Now, to explain what I mean by other things, what I mean to say is you can also find distance and time with this formula. You just need to move some stuff around. Let's just write stuff down according to this pyramid. According to this pyramid, you can find distance by multiplying speed and time. So let's just put that down, times time. And you can find time by doing distance over speed. To illustrate more of this, let's use some more real life examples. For distance, right? Let's say Timmy, I'll put TI for Timmy, can run 25 meters per second, and he's run for 10 seconds. Now, it stands to reason that we all know that Timmy can run 25 meters per second. If we know that he's run for 10 seconds, it stands to reason that if we multiply both of these values, we would be able to get the total distance that he has run, which is 250. Because of this, we know that distance is equal to speed times time. On the other hand, for this one, let's take Timmy again and say that he's run for, let's say, 500 meters, and he can run a total speed of 10. Wait, sorry, this is meters per second. That's for the speed. And he can run for a total speed of 10 meters per second. The thing here is, we can kind of just do the opposite now, because we know that for every second he covers 10 meters, and he's run for 500 meters. So if we divide both of these numbers, I'll just bring that here, we'd be able to get the total amount of seconds that Timmy can run. That's what I mean by manipulation, right? Just because this is the main formula doesn't mean you can't find distance or time. You just have to rely on this pyramid over here, and you'd be able to find all of that. Okay, now that we're done with that, let's move on to the second formula for this video. Velocity is equal to displacement over time. Now, if you've watched the last video, you'd know that there's not much that needs to change here, because, velocity and displacement are basically the same as speed and distance. The only difference is both velocity and displacement are vector quantities, which means they require a direction. So when you're writing velocity, let's say this car is going 5 miles per second, you'd have to put here the direction, let's say north. The weird thing though is in most problems, it already states where the car is going. Let's say the car is going north. Let's say the car is going 5 miles per second north. In the problem, it already says that the car is going north, which means when you're actually solving the problem, you don't need to add again that this car is going north. You just put 5 miles per second, and it's already implied the direction the car is going. But, just to be safe, usually you write the direction, and that's the only real difference between speed and velocity. The rest is the same, even the pyramid is the same. So just do as you would for velocity, whatever you did for speed. Now that that's done, let's move on to something a bit harder. Acceleration. Now acceleration is something that measures the the rate at which velocity changes over time. The reason that's important, and the reason why I mentioned it, is because it tells us that acceleration doesn't measure how fast something is going, it measures how much faster it is going in comparison to the start. To show you an example of why that's important, let's take a problem, right? Let's say that there's a car, let's say this car went from 5 meters per second to 10 meters per second in 5 seconds. Now, inputting that into the formula, you'd get something that looks like this. 10 is equal to minus 5 over 5 is equal to acceleration. And breaking this problem down, The reason why we're doing 10 minus 5 here is because we're trying to find how the change of the car's speed. We're not trying to find the car's speed. We're trying to find how much faster it is or how much slower it is at the end in comparison to how much faster in comparison to how fast or slow it was at the start. And that's why you subtract this part. So when you subtract this part, you'll get something like 5 over 5 is equal to acceleration. Breaking down the second part of the problem, the reason why you're dividing the change by time is because acceleration is something that finds the rate. And what that basically means is it tries to find the change per time unit. To clarify, a time unit is basically just the unit of measurement the problem chooses to use. So in this problem, we said that this car was going for 5 seconds. But if we said that this car was going for 5 minutes, then minutes would be the time unit. But in this problem, seconds are the time unit. But anyways, aside from that, since acceleration is something that measures the change per time unit, we have to divide the change by the amount of time units so that we can get the change per time unit and get something that looks like 1 meter per second squared. One last tidbit before I go. The reason why it's meters per second squared is because this is acceleration. If we were to put 1 meters per second just regularly, it would be speed or velocity, depending on if there's a direction added or not. But this is just speed. Because this is acceleration, it's 1 meter per second squared. This is acceleration. Okay, moving on, let's tackle this with some real problems. But before we do that, there is usually a scientific format given on how to solve word problems and problems in general. It's called GRESA. And to show you how this works, let's demonstrate its use in a simple problem. This one. A car traveled 60 meters at 5 mph. How long did it take the car to travel the 60 meters? No. So the way GRESA works is each of these letters stands for a different thing. If you remember the thing shown on screen, this one, G stands for given, R stands for required, E equation, solution, answer, stuff like that. And what given means in this scenario is what is given by the problem. So in this problem, it says that this car traveled 60 meters and it says what this car's speed is, 5 meters per second. Because of this, we write both of those down. First, we write its speed. Its speed is 5 mph. And then we write its distance, the thing that's given by the problem. So the problem also gives us distance, which is 60 m. Now, the next thing the problem does is it asks us a question. It asks us how long did it take the car to travel 60 meters. And because it asks us a question, it's requiring something from us. That's what R stands for. What question does the problem ask us? And in this case, it asks us a question of time. How long did it take the car? So we're going to put here time, and we're going to put a big old question mark next to it because we don't know it. We're trying to find this. Now, let's move on to the equation. The equation asks for the formula that we're going to use to solve this problem. For time, that formula is going to be distance over speed. So we're going to write that down. Then in solution, we take that formula and we substitute its real numbers. We know that the distance is 60 meters, so we put here 60. And we know here that the speed is 5 meters per second, so we put here 5. And then we solve it. T is equal to 12. And then we put the unit of measurement into the answer. So we put here T is equal to 12 seconds. Now, in case you don't know why I put seconds, you have to pay close attention to the problem. You see here, the speed says that this car is going 5 meters per second. Because of this, we know that the time unit is seconds because that's the speed that the car is going in, which is why we know conclusively that the time is 12 seconds, not just 12 units of time or whatever. Sorry for the very abrupt cut. The rest of the footage for the video you are watching were actually split into a part 1 and part 2. Part 1 is just the regular thing you saw. but the part 2 is going to also be uploaded on this channel on the same playlist, and it's going to have all of the advanced problems that we solved. um, just a heads up, the advanced footage that we cut from this video is around 8 minutes worth of content because it's really in depth and talks about all the different ways you can manipulate the different formulas. But for now, just for the sake of making this video short, we cut it and it's a part 2. For part 1, these are your guys' extra exercises, your guys' homework. The answers are going to be in the description, same with the questions. Make sure you answer them to make sure you understand all of the parts of this lesson. And I hope to see you in part 2. And if not, I'll see you guys in our next lesson, Type 1 Projectile Motion. That's it for me. I hope you guys enjoyed this video, and see you guys next time.